Hello, dear students. Let's see this question number 3.16 of Irodov. Very good question. So this question states a sphere of radius r carries a surface charge density sigma is equal to vector a dot vector r. A is a constant vector, r is the radius vector of a point of the sphere relative to center. Find the electric field strength vector at the center of the sphere. So let's go ahead. Here is this is the sphere of radius r, and a is a constant vector. So let me make any direction of a constant vector. Suppose I have drawn vector a like that, and let's take some position, any general position, and this is a position I've taken, and its position is a r vector. So at this point, the surface charge density sigma as given in the question, sigma is equal to a dot r, and I've shown in the diagram angle between r and a vector to be theta. So we can write this as a ar cos theta, and that is my equation 1. And let me take a strip around the ribbon type of thing around this sphere like this, and from theta to theta plus d theta, I want to take a ribbon on the surface like this. This is a ribbon, and the width of this ribbon is r d theta, and all these points of the ribbon will have the angular position theta with respect to the center. So at all these points we will have the same sigma, and width of this ribbon is r d theta. You can see that the radius of this ribbon, this is the radius, and that radius would be r sine theta, and distance from here to here, that will be, this is r, and that distance will be r cos theta like this. So if I cut this ribbon and stretch this out, so that will stretch out like that, and it will become a rectangular strip. The width of this rectangular strip is this r d theta, and the length will be, this is a radius of r sine theta, so that length will become 2 pi r sine theta. So area of this strip will be 2 pi r sine theta into r d theta. So charge on this ribbon, suppose that charge is dq. So dq will be sigma into dA. Sigma is ar cos theta. dA is equal to 2 pi r sine theta into r d theta. So overall simplification will give me dq is equal to 2 pi a, and this r that will be r cube, and cos theta into sine theta d theta. So now this ribbon that I am saying, this ribbon, that is kind of a ring, and this point of the center is the axial point of the ring. So because of this ring, electric field will be along this direction. Suppose this electric field is dE. Suppose if I have a ring and this ring has a charge dq, and at the axial position this is x, and from here this distance is r. So magnitude of electric field at this point has a formula k dq x divided by r cube. So I am going to use this result for that ribbon. So electric field here, dE would be k. K is 1 by 4 pi epsilon naught dq. dq is this, dq 2 pi a r cube cos theta sine theta d theta into x. X is r cos theta, and divide by r cube. So this r cube will get cancelled, and all the simplification will give me, dE will give me, this is 2 pi and this is 4 pi, so that will become 1 upon 2 epsilon naught, and a will be there, and 1 r will be there, and that will be cos square theta and sine theta. So sine theta into cos square theta and multiply by d theta like this. So now we have to solve this whole integration. So because of all these elements, the net electric field will be E will be integration of dE, and this will solve in the next page. So we had got this d is equal to AR by 2 epsilon naught sine theta cos square theta d theta, and for the all elements, or because of all the element, electric field will be along the same direction, so all the d will get added up. So net electric field will be E will be integration of dE, and for that integration the main issue is that trigonometric part by 2 sine 2 epsilon naught sine theta cos square theta d theta, and the limit will go from, you can see, as I take my limit from 0 to pi, it will cover the whole of the sphere. So limit will be from 0 to pi, and for that integration, let me take a substitution. Say I can take u is equal to cos theta. So du is equal to minus sine theta d theta. So sine theta cos square theta d theta, in place of sine theta d theta I can put minus du, and that cos square theta will become u square, so that will become minus of u square du, and that will become minus u cube by 3, and if I put back the value of u, I will get minus of cosine cube theta by 3, and that is the integration. And then we have to put the limit. So AR by 2 epsilon naught and minus cos cube theta by 3, and putting the limit from 0 to pi. So we will get this, on putting the limit, we'll get AR by 2 epsilon naught minus 2 by 3, and that would mean minus AR by 3 epsilon naught. And you can see, if you want to give answer in the vector form, all these d will add up, so the net electric field will be in the direction of each dE. So the net electric field will be like that, and this net electric field is opposite to the A vector. So in the vector form, I can write E is equal to minus A vector R by 3 epsilon naught, and that is the answer to this question. Thank you.